Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog.
This episode is sponsored by our friends at Rollbar. How important is it for you to catch errors before your users do? What if you could resolve those errors in minutes and then deploy with confidence? That's exactly what Rollbar enables for software teams. One of the most frustrating things we all deal with is errors. Most teams either A, rely on their users to report errors, or B, use log files and lists of errors to debug problems. That's such a waste of time. Instantly know what's broken and why with Rollbar. Reduce time wasted debugging and automatically capture errors alongside rich diagnostic data to help you defeat impactful errors. You can integrate Rollbar into your existing workflow. It integrates with your source code repository and deployment system to give you deep insights into exactly what changes caused each error. For our .NET friends, adding the Rollbar.NET SDK is as easy as adding the NuGet package and your API key. It supports .NET Core, ASP, MVC, Xamarin, and more. Give Rollbar a try today at no cost to you. No credit card is required. Our listeners get access to the Bootstrap plan with 100,000 events for free for 90 days. To get started, head to rollbar.com/changelog.
All right, welcome back, everybody. This is the Changelog podcast featuring the hackers, leaders, and innovators of open source. I'm Adam Stacoviak, editor-in-chief of Changelog. Today, Jared and I are talking to Daniel Stenberg about 20 years of curl, what a history that is, what's new in HTTP2, and the backstory of QUIC, a new transport designed by Jim Roskind at Google, which offers reduced latency compared to that of TCP plus TLS plus HTTP2.
So Daniel, we last had you on the changelog when curl was 17 years old. Now curl has turned 20, and a lot has changed in those 3 years. But I think we should start with this quote and from a tweet that you put out recently, which I loved and we retweeted, which said, 20 years of maintaining open source, and all I ever got is an awesome career, friends all over the world, and a gold medal from the Swedish king. You got to start with the gold medal, right? Get to the important stuff first. Tell us this story.
So I was awarded an engineering prize in Sweden. It's named after an old Swedish engineer called the Polhem Prize. So it's an old distinguished prize that they have been handing out for, I think, 120 years or so. Really a prestigious prize given out to engineers and inventors of different things over the years. And in 2017 I was awarded and given this prize. And it comes in the form of a gold medal and a cash part. And
nice.
At the award ceremony in October, I believe it was, in 2017, I was awarded this gold medal from the Swedish king who was there and gave it to me. So I got to shake his hand and say thanks.
That's awesome. And in the tweet, which is linked in the notes, there is a picture of you shaking, I assume that's him, the Swedish king's hand there.
Exactly. Yes. Yeah.
Now, you just tweeted this a few days back, May 18th. We're recording this on May 22nd, 2018. So on a time delay, did something bring it to your mind, or did you finally get a copy of the picture that you could share? Why the delay on the tweet if this happened back late last year?
So I brought it up from a completely different reason, actually. It was more, I previous to that tweet, I tweeted another image that was one of these funny things, about one of these fake O'Reilly covers from a book that says thanklessly maintaining open source and a sad llama on it, as if sort of, more of the constant mantra that is maintaining open source is a bit of a thankless job many times, and we do a lot of things, and then someone replied to me and said, well, you got a gold medal. So I just had to sort of show the other side of the coin, really, because I think I have gotten a lot of good things from open source and I enjoy it a lot. So it's really not it's not an ordeal or a struggle for me. It's a pleasure, and I do it for fun. So I just wanted to bring out some of the goodies and
Yeah.
goodness that I experienced from working with open source.
Well, this is only your second time on the show, but it's probably the umpteenth time that your name has been mentioned since we had you on 3 years back, because you impressed us so much with the 17 years of dedication to curl and just this relentless pursuit of what is, such a popular, widely used tool and so relied upon. Like, this is definitely the web's infrastructure type of a thing. And so many people burn out, fizzle out, projects change, corporate interests, like so many things go what we might consider wrong in terms of sustainability. But with you, it's like you're 20 and you're still rolling. Do you have a retirement date in mind, or what are you thinking for this?
Sometimes I think about what I would do if I wouldn't do this, but no, I'm still enjoying this so much, and I don't see anything else that I want to do as much as this. And so yeah, this is really my baby still, so very much so I keep on doing it for the fun of it.
The thing that is kind of interesting about the 20 years aspect is not so much the length of time, but the amount of time, I guess, is somewhat the same, but a slightly different side of the coin, is that it's been involved in your life. Like, it's been a part of your life since 27. I'm assuming since it's 20 years, you're now 47, doing some basic math here. It's a lot of time. That's your 20s, your 30s, and your 40s, basically. I mean, it's a lot of time.
It is totally a part of my life, and I've been doing it. I've started. I mean, the first code I wrote was even before curl, so it's strictly speaking more than, it's like the 23 years. And yeah, it's older than my kids. It's older than my house. I've switched jobs like 3-4 times since then. So it's one of the most constant factors in my life. Really, it's just been with me since forever. So it's really something that I don't really consider giving up ever, really, because it's me, really.
Do you own the full copyright to curl, or is it community? What's the structure, like the maybe the legal implications to like the ownership of it?
I own most copyrights, but not everything. I haven't really been very strict about it either. So if people contribute a larger chunk that they want to have their copyright on, that's fine. So we have a bunch of different other copyright holders on various parts, but I would say that maybe 70-80% of everything has my copyrights on it.
I asked that mainly because of the question Jared asked, which is, what are you going to do? What would you do otherwise, essentially? At some point you'll have to pass it on.
Yeah, of course, yes.
By force or by desire.
Exactly.
Not being morbid here or anything.
But it is open source, and it's licensed extremely liberal, so anyone is free to continue wherever they feel like at that point, or at any point, really.
Kind of reminds me of this conversation we had off air at Build with the Python team there, Adam, about really the passing down of the torch from Guido van Rossum to whomever is next with regards to the Python project. And when you have a BDFL, if that BDFL is really good at doing BDFL things, everything goes well. But eventually, there needs to be a passing of the torch. Have you put serious thoughts into that, or are you far enough away? Of course, with that, we always bring up the somewhat morbid conversation of the bus factor. Like, what if something bad happens to Guido or to yourself, Daniel? But more likely, like, an eventual retirement from software or from open source. Is that something that is actively in your mind, or does it just feel like it's really far away at this point?
Both, yes. And I would say that it is active in my mind, that in the regards that I've been thinking about it, and I've given it thoughts about how to do it at some point in time, but it's not something that I consider doing anytime soon, sort of hand it over to someone. My ideal case, or my ideal situation, would be that it would, within the project, there would be 1 or 2 or 3 persons that would be sort of the natural other people that would take over if I would just get bored one day, and they would just more or less transparently just shoulder the tasks that I've been doing and just continue in whatever means they think they should do it. But I'm at the same time, I know that the way I do the project, I also know that I have a pretty strong presence myself. I think that I sometimes also, I don't let others sort of reach that level sometimes before, because I think I sometimes do a little bit too much myself. Why wait for someone else to do it when I can do it myself, sort of.
Yeah.
And I think that sometimes isn't constructive in that regard, that it doesn't really encourage others to step forward and show their abilities.
But it's also, in one sense, very much so your life's work. And so, talk about difficult to pass on or to let go, even if you know it's constructive on the long term, to let more people into the fold, or the ones who you trust, to give them more responsibilities or allow them to come into that. When it's like, curl, it's curl. It's your project. It's hard to let go of that, right?
Synonymous.
Right. Yeah. But of course, I would like the project to be more distributed onto more people than we are right now, and I'm trying to make that happen, but it's not. I think I've sort of laid the groundwork for one way to work, and it has sort of developed into this. So it's not that easy to just say that, no, I just want to do a little part in my corner here. You go ahead and do everything else, because there aren't that many others who are prepared to jump in and do the others stuff. So
especially if we, I can recall several years ago when we talked to you before, you mentioned how some of the income you've been able to make obviously has been because of like contract jobs that you've done for various companies to add features or specific things. And, I'm just imagining that it's very difficult to like piecemeal and like break off some of that whenever it's so kind of you focused in the minutia of it. And it's not exactly, I don't want to say not the funnest tool to work on. I've never done it, obviously, but it doesn't have this lore like some other popular projects might have, like, hey, come and be a contributor and, you'll have this glorious open source lifestyle. I don't know. Like, I'm not sure there's much draw. How do you draw people into this project with you?
Yeah, that's a good question. I don't know.
I mean, it's the pipelines of the internet, right? It's internet plumbing.
Yeah, and I think that might be what attracts people then, because it's a sort of a fundamental thing that
massive
exists
effect
everywhere. Yeah, so if you contribute to curl, you can get your little piece of code into a couple of billion devices over time.
Right.
That is, of course, an interesting sort of feeling or challenge.
Wow, I didn't consider that. Okay, I'll take it back.
It's one of the things I've been thinking about. I've been putting off a blog post about developer and leveraging software. And I feel like software developers live at what is perhaps right now the height of humans' ability to leverage things. And the fact that you can write one line of code, Daniel, and then do a release, and then that's going to get, eventually it has to trickle down and go through the release process, but that's going to affect, billions of devices, millions of people. That is an incredible amount of leverage. And I do think that that's attractive from a software developer's stance, because how can you live the most meaningful life? It's to have the most positive impact on the most people, and software really lets us do that.
Oh, absolutely. Sort of just do something little in my corner, and it can seriously influence the entire world in some ways, at least.
So let's zoom out and talk about your community a little bit, because as I've been watching curl and your blog more closely since you were on the show, one thing I did notice is you do keep it fun. You do celebrate victories, like your 20-year celebration post was awesome with like the Titanic reference, and I can tell that you're still lighthearted and having fun with it, even though you've been doing this for 20 years. You have a curl conference now. You got stickers. Tell us about some of the stuff you're doing in the community and who all is part of it with you.
Yeah, I think all these other things around the project, like that isn't code, also makes it fun, because some of the oldest other contributors or maintainers in the project, they've been around for, I think the oldest guy has been a little over 15 years now. So some of those are really my old friends by now. So it's very, so setting up a little conference to meet over a weekend and just talk curl for a weekend, I can't think of much other things that are better, more fun to do in the weekend. And so that's just awesome. And of course then sort of making one thing about becoming more known and things like getting awards and prizes makes people get your eyes open and see us in slightly different sort of lights or angle, is that suddenly people approach us with money or ideas, and they can print stickers for us and hand them over, or they can borrow us their conference rooms for a weekend or stuff like that. So stuff also gets easier when you get known, or people realize the impact, so people get friendly, and we get friends all over. So that is fun. So of course I like curl, and I like working with it, and of course I then try to sort of bring up those fun moments, like celebrating 20 years of curl, or now we broke the sort of, we have 32,000 questions or Stack Overflow, or now we have 1,700 contributors in the thanks file and stuff like that. So because I wanna help out the other contributors and everyone to make sure that they feel appreciated, and we all appreciate what they do, and I think it's fun.
Yeah.
It also goes back to this constant question that I say that, yeah, I've been working with curl for 20 years, and then the constant, whoa, I used it for 10 years ago and it worked exactly the same. What have you been doing?
I think we asked you that on the last podcast.
That's actually one of our questions, was what's new with curl? What have you been doing these last 3 years?
What have I been doing? And that's a completely natural question, and it's it's not a bad question. It's just that, when you're working with something and the sort of the facade or the front, it's the same, and the whole point with the tool and the library is that it should work the same way. We work really, really hard to make sure that it keeps working the same way. But of course we added a little stuff and we fixed bugs and stuff. But the point is that it shouldn't, you shouldn't realize that a lot of stuff underneath actually changed, and we sort of replaced half of the engine and added a lot of other things, or documented everything again in another way. You don't have to think about that. But sometimes when I want to sometimes help people, or people in the project and people around me, to realize that we are actually doing a lot of things that even if you may not think of all these changes, and you used curl the same way 10 years ago, we've actually also added a whole busload of things just the last few years, and here are some of those things that you can now do that you couldn't do before, and blah blah blah, why that is good, and how this helps your application or your usage of this in the future, and so on. And also sort of we're having a slide, I don't know if I should call it feature creep, but we're adding a lot of features. We have a lot, we have 215 command line options.
Wow.
Sometimes I feel a need to highlight parts of that to help people actually find out about things that curl can do.
Almost discovering, hidden features or hidden gems, so to speak, because you're not paying attention to the changelog or whatever.
Exactly. So even if the things might not be new, I can sometimes just write about it. Well, imagine if you want to do this, you can actually do it like this, with curl. You've been able to do it for a long time, but maybe you didn't think about it.
Has anybody ever written like a curl cookbook or some sort of thing where it's not necessarily like it's just a pamphlet, or maybe it's even only digital, but is like, here are 25 things that you can do with curl, and then the specific examples of those commands, because that would be so useful.
Yes, there are pages like that. So I try to do that sometimes, but I'm not the right person to do it. I'm so entrenched in the details, so I just get lost in. I've actually written a book about curl that I'm posting online. That's that I call everything curl. That is really everything curl.
So is it going to be like a big like a curl Bible kind of thing, or is it going to be like, how long is it? I guess that's what I'm trying to get at.
It's long.
That's kind of how I thought it might. You might say it's everything curl. I'm like, well, that might be too much curl.
Yeah. It is. You can find it. You can just Google it up, and it's like, if you print it, it's like 250 pages or so.
Is this an ongoing thing? I mean, it sounds.
It is an ongoing thing.
Started in 2015-ish, something like that. Late 2015.
Yeah, exactly. I think it was after our last podcast. But yes, it's been going on for several years, and it's never going to end either, because it's just so much. I know curl changes all the time too. So if I want to keep up, I need to keep up with the book.
Right.
Yeah. But it's an effort to be to describe curl and how to use curl in a way that isn't really just man pages and reference documentation, but actually sort of help people to read up about it in a different way.
It's kind of like a did you know kind of thing. I think that would be so useful. I was thinking, kind of a callback to a recent show. Maybe there's a dev hints out there for curl, and of course there is. So devhints.io/curl. This is kind of what I'm thinking, but it's light on examples. There's 3 examples. And I think you could probably come up with some complex use cases where this would be super handy for this particular thing. And then here's your curl command. One thing I have seen a lot of, which is really neat, is different HTTP tooling, specifically like some desktop apps for Mac will actually have like an export to curl button once you've crafted a specific request, right? And then you can just like get the curl export and put that in your terminal, and that's really cool.
Yeah, the copy as curl has really become a popular feature, and I like that too. Since now I know, I mean, Firefox, Chrome, and Safari now, all of them have this copy as curl if you're using their dev tools, so you can copy from their specific, if you watch the network traffic from your browser, you can select a particular request and do copy as curl from that. So yes,
spectacular for trying to replay a very specific thing in the terminal, and capture the output or whatever you want to do from there.
Oh yeah, it's really handy, and it's a great way to learn how to use, if you want to do something with curl and it's roughly this that my browser just did, and just get a copy and edit that command line. I mean, the command line is usually quite long and
213. That's a lot of features.
Yeah, but right, and they're often really repetitive because the browsers, they set a lot of headers, so you want to have the exact headers like the browsers do, so they set a lot of them, very long command lines. But still, you can look at that command line and see this is how you could do it.
So speaking of headers and speaking of features, I actually found on your blog recently a feature that I'm very much looking forward to, which is a small change. But you said like the core feature set changes, has stayed the same, and people say curl works exactly like it used to. There are some, you're doing some UI brush-ups, specifically with the -i command, which is probably like if you go through my history with curl, like in my command prompt, you're gonna find curl -i, capital I, of course, almost every time, because I use it for looking at headers. And you're adding like bold key values on the headers, so the header names are bold, and then the value, the text is not bold. So that's like a very small thing, but you're not ignoring the facade or the paint. You're still making small improvements to the output as well.
Yes, and sometimes I have a hard time to decide what to focus on. But I think it's fun to do that too. So I try to sort of move around a little bit. I can work a little bit on how things appear on the command line. I changed one of the progress bar outputs a while ago too, just because of it actually makes it is somewhat important to some people, and why not? And it's fun to work on that sometimes, and then go back to debugging HTTP2 streams for another day. But so I mix up, and that was what makes me, of course, enjoy this, since I can do various things. I can play with the UI one day and then go back and work with protocol stuff another day, and then work on documentation a third day, and then write a blog post another day. So yeah, so I've actually just landed in Git, so it'll be for the next curl release the code that outputs the headers as bold. Well, the name value is the name part is bold, and the value part is not bold. It's actually a very, very long time coming feature request.
Well, I'm sure a long time coming, but you also mentioned that this was not an insignificant amount of code change. Maybe you weren't set up to do this kind of output, or why was it a bigger feature than maybe people would think it is in terms of implementation?
No, I think it was because it involves I think it's mostly a lot of internal decisions on how to do HTTP and show headers, and we have this concept of headers, and curl supports a lot of different protocols. And some of them have the internal concept of headers, but I only wanted to do the bold for HTTP headers. And then I've used so it was mostly because of how I had done this with curl until now, or not done it. And also when I had to change how, I don't know how to explain it, but headers come, from until this here, carriage return line feed at the end of the line. So you want to make sure that you actually do this on a complete header and not on a partial header. So if it would be an extremely long header, it would come. I would still need code to handle that. I only do left part and not the right part of it. So it was a lot of, finicky internal things that made me...
Good old-fashioned yak shave.
Yes, and sort of, I've done a lot of decisions a long time ago that was convenient because I didn't do this. And now when I had to go back and make sure that I could split up the headers like this, then I had to just, remodel a couple of things and shape it up. But I think it was all good. I think I improved some other tiny things in the process. And I know that a lot of people will appreciate getting the headers bold, however small it may sound. It's one of those details that makes it look better.
This episode is brought to you by DigitalOcean. DigitalOcean is a cloud computing platform built with simplicity at the forefront, so managing infrastructure is easy. Whether you're a business running one single virtual machine or 10,000, DigitalOcean gets out of your way so teams can build, deploy, and scale cloud apps faster and more efficiently. Join the ranks of Docker, GitLab, Slack, HashiCorp, WeWork, Fastly, and more. Enjoy simple, predictable pricing. Sign up, deploy your app in seconds. Head to do.co/changelog, and our listeners get a free $100 credit to spend in your first 60 days. Try it free. Once again, head to do.co/changelog. So I guess we came to this conversation through an embarrassing moment for me. It was early in the morning on a Sunday, and somebody in our Slack, Daniel, had said, "Hey, what's the state of HP2 and where's it going?" And I'm like, "Great question. We should ask Ilya. We've had him on the show a while back, and it'd be great to catch up." Sent him an email with the subject line "Current state of HTTPS?" not 2, and I had to quickly check that because that was obviously not right. But was reaching out to him to essentially get an update on TLS 1.3, QUIC, and some other stuff. So maybe help us kind of understand. So he said that you're working on this. You got a lot of stuff going on. What's going on?
There's a lot of stuff going on. Well, HTTP2 that shipped. I mean, the kind of 3 years ago, right? Our last episode, and the RFC was published in May 2015. So yeah. So, and now 3 years later, the work is, of course, then no longer going on standard-wise on HTTP2 very much. There are still things happening in HTTP2, but the fundamentals is there, and it's good, and it's working, and it's being used. I could just add then perhaps that if we look at traffic done by Firefox, we can see that Firefox is using HTTP2 in, I think, about 75% of all HTTPS traffic. So I would say that it's a pretty good, a significant amount of the traffic is HTTP2 now. Counted by volume, then of course, if you look at the other way, sort of, how large percentage of all the web servers in the world that are providing HTTP2, it's not as nice numbers. Then it's upwards. I think we're approaching 40% of the top 1,000, and the top 10 million is like 25% or so. So it's but it's still moving, and I think the numbers are still rising pretty quickly. I think they've doubled roughly the last 12 months or so. They've been doing that for a while. So it's growing, and it's being used, and it's being understood, and I think there are areas that have been more successful and some that have been less successful in the protocol. And I think already when HTTP2 shipped, there was this notion that the next protocol revision wouldn't at all take 16 years to happen. It would happen much sooner.
That would be nice, wouldn't it?
Yes, and a lot of the HTTP2 work was also laying the foundation to make sure that we could iterate protocol versions much faster and easier and more effortless in the future. So the HTTP2 brought a lot of that infrastructure. So what is happening, and at the same time then when HTTP2 shipped, Google had already been running their QUIC experiments in the public, with in their Chrome browser and in their server side, since I believe they went public, I don't remember, 2013 or so, with their QUIC efforts. Anyway, Google took their efforts to the IETF and said we should make a standard version of the QUIC protocol. They did that in 2016, late 2016. And QUIC being an experimental protocol that Google invented then, which is HTTP2-like, but it's done over UDP. And since then UDP isn't, it doesn't have any, it's not reliable, it doesn't do retransmissions or anything, and there's no security in there or anything. So you basically implemented a transport stack basically a TCP-like stack that also features security then, because you want to have the not HTTPS but HTTPS-like.
So you have UDP and TCP. Don't those operate kind of at the same level of the stack? So why would you take UDP and then make it TCP-like? Doesn't that sound like
exactly?
Okay, you're
exactly.
with me.
Well, I can take one step back first. Why wouldn't you invent a new protocol? Like, why, if you want to make it better TCP, why not make a TCP2 in parallel to TCP? But that has basically been ruled out because of all the middle boxes and NATs and firewalls and everything in the world that makes it really, really hard to introduce any new transport protocols nowadays.
So we're stuck.
Mm-hmm.
So we're pretty much stuck. TCP, UDP, those are the ones we have to choose between.
And so now the answer is, well, we can't change TCP enough to make it faster, better, more secure, but we can take UDP, which is very lightweight and doesn't have any of these things that TCP has, and make it TCP-like, but not with some of the trappings, I guess?
Exactly. By choosing UDP and basically do it all yourself, you can basically decide how to do it. Well, just do whatever you want. And in Google's case, then they have a fairly large client-side implementation and a fairly large server-side implementation. They were in an excellent position to experiment with doing their own protocol over UDP and implement all this and check it out. How does it work? And it worked really good. And they figured out that this is a protocol we should make a standard for the web and the internet.
Can either of you give a 10-second/60-second version of the difference between TCP and UDP?
TCP is like setting up a string between two computers, a physical string, and you pass on data in one end and it will arrive in the other end, or it might get connected, but the data will arrive or not arrive at all, but it will arrive and it will be unaltered, and it will arrive in the same order that it was sent from the sender. So it's basically a way to transport data and make sure that it's a reliable transport, and it's in both directions.
Mm-hmm.
But UDP, on the other hand, is basically just sending notes in the air or whatever, writing pieces of paper and throw it away over.
Message in a bottle.
It might arrive, it might not, and it might arrive in another order too. So it's much more lightweight, and it's been used for for DNS, and traditionally for DNS, NTP, and traditionally also for RTP, for video.
Yeah.
But really never on a really wide scale, high speed internet scale like this. So that has always been one of the biggest concerns. Will UDP break stuff now, because we haven't designed things for UDP at this level? But over time it has proven that most of the things actually work pretty well anyway, and over time people have also adjusted things and improved infrastructure and routers and things, so things are going better. And looking at Google's numbers, they claim that I think my number is old now, but they said already like a year or two ago that 7% of internet is QUIC already, and that's quite a big share of data running.
So QUIC is the new version of what H2 has been, right? The evolution of H1 to H2 is now coming to QUIC, and
QUIC QUIC is a lot of things. Because first it was the QUIC that Google made,
right, and now it's evolved to something else.
Yes.
I mean, because it's a long time ago too when they started this. Like I think 2013, 2012 or something like that when QUIC was begun.
Yes, exactly. So I think they went public with it in 2013, but then they had already been working on it in private before that. But then they produced what I call Google QUIC, and that is basically sending HTTP2 over UDP with a custom encryption code. So you could almost use your HTTP2 implementation and just provide that QUIC stack, and it would work. But when they took that protocol, well, they kept up with documenting how the protocol worked, and they had a website for everything, and they made it all in the public. And they took their latest update of the drafts to the IETF and said we should document this protocol. This is QUIC from Google and blah blah blah. And when they brought it into the IETF and they started to look at it and decided on how to move forward on this, they came to the conclusion that this bundled solution that is one transport protocol that is only sending HTTP2 wasn't ideal for a protocol or a transport like this. So they came up with a conclusion that QUIC should be split in a transport part and an application part. So it should be able to also transport other things than HTTP. And DNS was one of the first things that were discussed and has been one of the sort of second protocols that have been in discussion all the time. So then QUIC became QUIC the transport, and HTTP over QUIC is the new HTTP.
Is that the final version of QUIC, or is that a transitionary version as well?
Well, it's not final because it's not done yet. So they took it to the IETF, and they created a QUIC working group in the IETF, and within that group there has been a lot of activities since then. They're now doing draft 12 of the specs, and they have 4 different specs, I think. The plan is to be done by November this year, 2018.
With the spec?
With the specs. Or there are multiple. So there are several. I think there are 4 or 5 specs. But yeah, I don't think they will stick to this plan because there are still too many loose parts and moving.
I guess the question might be, as a zoom out, might be, this is all in an effort to obviously make progress, but to make it easier to iterate on something that has been traditionally harder to iterate on.
Yeah, but also sort of when HTTP2 shipped, we all were aware of a lot of shortcomings and things that we could improve further in the transport protocols. So when we went to HTTP2, we improved a lot of things from HTTP 1.1, but there are still a lot of other things that HTTP2 can't really do, and where it has bottlenecks or problems that we can solve. And we couldn't really solve them with the TCP in the HTTP2 context, but going to QUIC, we can solve even more problems. Some of those problems that are still present in HTTP2. And there are, I mean, apart from just fixing things in TCP, fixing things in TCP is really, really difficult in general, because of not only, there are many reasons why TCP is difficult to change, but 2 of them are that, again, we have a lot of middle boxes over the internet. You're talking through NATs and routers and everything, and they know, with air quotes, how TCP works. So if you change how TCP work slightly, you add a little thing here and there you break X% of those boxes, and they will refuse to send it because they know that's not TCP anymore.
You mean if you're just tuning parameters, or if you fundamentally change the protocol? Because tuning parameters, they shouldn't break. That would just be really bad programming on those boxes.
Well, yes, but that's the reality. Just as a sort of a little story into this, one of the features they added in TCP, I think it's 7 years ago, they added the TCP Fast Open, which is It's a way to send the data already in the first SYN packet in TCP. You know, when you do a TCP handshake, you do a SYN and SYN. There's a three-way handshake. So in order to gain round trip, they invented this method where you could add data already in the SYN packet, in the first packet. So you would save a round trip, you would get data earlier. And you know, a lot of this struggle is to get data earlier, you know, soon reduce round trips, get data earlier. So sending data already in the first packet of TCP, that's potentially, you know, saving, well, if not tens, but sometimes hundreds of milliseconds if you're far away. So that's a huge benefit. But implementing and using this TFO over the internet today, it turns out to be a struggle and a pain to make sure that works, because there are so many machines out there that blocks that little new bit that comes saying, here's a TFO. No, that's not TCP the way we want it. Deny.
Yeah, that's a tough problem. I mean, you just have so much infrastructure out there. It's not feasible to like change the boxes in the middle, because there's just too many owners, too many places, too many situations that you're never going to be able to replace those. Exactly.
That's what they call ossification nowadays. So the grand solution to that is encrypt everything. Because so that none of these middle boxes can actually, you know, peek into those little bits and bytes.
Sniff your packets, yeah.
Exactly. They can't figure out you wanted this because they don't know it. They just have to pass it on. So then you can add things over time. So that is one reason why QUIC is now really, really encrypted to as much as possible, really. So, but that shows how it's hard to change even TCP over the wire. But then also just changing, you know, in the implementations of TCP, they're kernel-based stacks, you know, it takes forever. This TFO implement, then the spec came 7 years ago, is only like a year ago or so that Windows finally implemented it widely. So it takes forever for this to be implemented widely. So if you want to iterate fast, you can't do it like that. And then there's this another technical problem with, for example, for that TCP has and HTTP2 shows is a problem with packet loss. You know, when HTTP2 was introduced, it was the new method of doing transfers is to do a lot of streams over a single physical connection. So you would typically do 100 streams over the same TCP connection, just a lot of logical streams over it, which is a good way to do a lot of parallel transfers, but only using one connection. And this is really good as long as your network is decent. And it turns out then if your network turns out to be very lossy and you start losing packets, then having just a single TCP stream or TCP connection is really not ideal, because then losing one packet in the middle there, that means that you're waiting for one packet to get resent to get those 100 streams continue. While as previously you would do typically perhaps 6 connections per host, and you would do sharding, you would maybe have 20 connections or 30 connections with HTTP 1.1 to sites.
So it's almost like faster networks get faster, but slow networks get slower. Slow as it's unreliable, maybe is the better word, not slow, but unreliable.
Exactly, slow as in bad connectivity, bad radio and stuff.
Yeah.
Exactly, because H2 is really good if you're far away. So for people really, really far away from their servers, it's excellent. It's possibly those who actually gain the most by H2.
Because they need to make less TCP connections?
Yeah, and much less round trips. So you can, fire off 100 requests at once, basically, and get the responses when instead of, this ping pong request, response, waiting, sending, waiting, sending. And so, this TCP limitation is not there in QUIC. In QUIC, you create connections, but they're not connections in the same way as TCP has them. So when you're sending the streams themselves are reliable within the stream. So you can send things, and you know that the picture or image or whatever you send, it will arrive in the other end unmodified and exactly as it was sent from the source. But the streams, they are independent from each other. So if you drop a packet somewhere in the middle that belongs to stream 1, stream 2 can still continue because it still has all its little packets. So it's only the one that actually has lost packets that has to wait. So this makes the lossy network situation completely different, because then if you lose a few packets somewhere, yeah, sure, those streams that belong to those that actually have lost packets, they will have to wait and resend the packets and everything. But the others, they can continue.
Sounds like thank goodness for UDP, because it's provided us a loophole around the ossification, right? Like we would have been stuck if this UDP hack wasn't available to us.
Exactly. It is exactly like that. So yeah, that's why it has to be UDP, and that's why we're doing all this work, implementing TCP-like stacks in user space in both ends. So so QUIC as a protocol is, I would say, far more advanced than H2 then, because now you also have to implement the transport part and then the HTTP part on top of that.
Open source is what fuels new industries and pushes long-standing ones forward. In its 20th year, OSCON continues the tradition of bringing you the latest technological advances and a path to successfully implement open source in your workflow. OSCON 2018 features frameworks like TensorFlow, MXNet, and PyTorch, to blockchain projects like Hyperledger, Bitcoin, and Ethereum, as well as infrastructure disruptors like Kubernetes, Prometheus, and Istio. You'll get an insider's look at the open source implementations that will have the most profound impact on your business. Enjoy new events like live coding sessions and the OSCON Business Summit, and don't miss the fun evening events and receptions, the Open Source Awards, and plenty of networking opportunities for everyone. Save 20% off with code CHANGELOG on gold, silver, and bronze passes. Head to oscon.com to learn more and register.
Daniel, what if you were just to describe QUIC's mission, what would it be?
It would be to reduce round trips and work this pretty much transparently the same way as H2, but better and secure by default and always. There's no clear text QUIC. And of course, that is the HTTP over QUIC, how that will appear. There will be more QUIC after this QUIC.
There's more QUIC coming after this QUIC. Wasn't H2 supposed to be all encrypted too? And maybe they backed up on that at the last minute?
Yeah, exactly. Well, H2 in reality, I would say over the web, on the internet or the web, is encrypted always. But the standard allows for both. Yeah, exactly. The spec is sort of, you can do it either way. But for QUIC, there's no unencrypted version. You need TLS 1.3. That's sort of, you can't avoid it.
You said there's more QUIC coming. This QUIC hasn't even arrived yet. How can we look for that far down the pipeline?
I think that is, maybe we don't have to care about it right now. But
phew.
But when I said this, when Google took this into ITF, they decided we should split it into transport and application, and the application is HTTP, and we should prepare for another application, maybe DNS. And then they also said, oh well, we also want QUIC to be able to handle multipath, which is, I don't know if you know about TCP, multipath TCP, but that's setting up multiple paths between two endpoints over the internet. But then they decided that maybe we don't have time to get into multipath in QUIC v1, so we postponed the multipath part. So there's already this talk about but then QUIC v2 will be making sure that we can actually do DNS and do multipath and stuff like that. Basically postpone because it hasn't been enough time to cram it into version 1.
So you mentioned earlier that 7% roughly, and that might be an older number of the internet, is using QUIC. Specifically, if you're using Google Chrome and you're speaking to Google services, you're most definitely using QUIC and just don't know it. What about the rest of us? Like, what's the roadmap look like in terms of adoption or production use, and when we should start thinking about this? Many of us are still trying to get on H2, and so maybe this is a little overwhelming, but maybe you can skip H2 and go straight to QUIC. I don't know.
I would say that, I mean, yeah, I get that there's some notion of that. And maybe if you haven't gone to H2 by the end of this year, maybe you should consider just going to QUIC at once. But I don't know. Well, the Google QUIC was not implemented by many others than Google alone. So the Cadia server has an implementation, and there are a few other standalone implementations, but they have never been widely deployed or adopted. So the Google QUIC version is primarily used by Chrome and the Google servers. So that is basically what 7% of the internet traffic is. But the IETF version of QUIC, which is then quite different over the wires since of this divide, and they changed the crypto layer and they changed pretty much everything in the protocol. So the IETF version of QUIC is being implemented by a lot of different players, all the ones that you can expect then. I mean, the browsers and the big server vendors and the big service vendors like Facebook is a lot on it, and the CDNs too. So going into the future, we will see this getting deployed and used by all the big players that were involved with H2 deployment.
So are you working on this on Mozilla's behalf, on curl's behalf, both perhaps? How does it fit into your life now?
Well, I'm actually not that involved in QUIC. Okay. I'm mostly I'm participating. I'm reading the traffic. I'm getting the news and sort of following. That's a steady stream of GitHub issues and stuff like that. So yeah, I'm participating a bit for both interest from a Mozilla perspective and a curl perspective, but because of course I want to make sure to learn and know how it works and understand everything, and then as soon as it becomes possible and I get the time and energy, implement it to support it in curl.
What kind of timeline would you expect for that? Would you wait for the draft needs to be like formalized, right? So that November 2018, what they're shooting for, you wouldn't start any sooner than that, would you?
I would, depending on things. But
tell us more. What things?
Well, it's like building a tower or something, or building a house. When can you move in? Or when I implemented H2 for curl, I went in pretty early and started implementing support already in one of the drafts, I think a year before it finalized, and that turned out to be really useful, both as feedback back into the standard process, but also a lot of just trying out things and getting everything working and interoping with all the other implementers. So I think it's really useful to get in as early as possible, but not too early from my point of view, because in the QUIC world, and of course there's so much transport here, and I want to have the transport part fairly done by the time I start adding the HTTP parts on top of that transport stuff, and then I need to cooperate with others to do this, to do a library, or there is already many libraries of course that implement this, but I'm having a particular one in mind, and I want to work with those guys to make sure that we get a HTTP over QUIC library that works fine with curl and that I can make sure that curl uses. I'm expecting us or me to start doing that soon. I've actually thought I had already started by now, but I think the spec hasn't really moved on as fast as I anticipated it, and the library is also not really there, and I haven't really had the time. So well, maybe in a month or so, I would say, hopefully during the summer I could get a start on it.
Well, we talk about the ossification of our infrastructure, and at least in curl's case and on the software side. And on the client side, we appreciate that you are so eager to jump in and to help, beta test, if you will, the implementation of these things, and maybe even write one of the early client-side implementations of supporting these things, so that we can continue moving forward. Because when curl, adopts something, a lot of devices around the world now can speak that language, right? So that's pretty cool. You mentioned DNS as the other potential application of QUIC underneath DNS. I'm assuming there you wouldn't gain any speed, because UDP alone has got to be faster than QUIC, right? Because QUIC has additional things, but there you're gaining that encrypted connection. Are there other? Am I on point there?
Yeah, and I think there's an even greater sort of there's a bigger goal here too. I mean, there's this this term that has been used within the IETF several times that I can drop here, that they talk about the post TCP world. If you want to go to things completely TCP-less, then you need to do the other protocols over QUIC, basically. And I'm not sure why they picked DNS as the other protocol to use here, because I mean DNS has its own road forward in other ways, so I'm not sure exactly how this is going to turn out. So I can't really speak much about why they picked DNS or what they're anticipating, what they want from that over QUIC, because nowadays we see a lot of DNS going over TLS and DNS over HTTPS coming. So we're already sort of fixing up the security parts and the privacy parts for DNS like this. So I don't know.
So a post TCP world. I've never had this consideration, so this is my first time even thinking about what are the implications. Dan, you probably thought about it a little bit more. What does that imply? What does that change? Seems like a simplification, but maybe not, because you got to put so much stuff in QUIC.
One of the interesting things without TCP is what is an HTTPS URL really, right? So or an HTTP URL for that matter, but HTTPS URLs, they are basically implying TCP, right? Or HTTPS is, since I mean they're not saying connect to me on UDP port 443 anyway, because you probably don't have that. So that's one of the greater challenges, is how to move away from that. And I didn't mention that, but the way you bootstrap into a QUIC world from HTTP or HTTP2 is that the server is replying with an alt services header saying you can connect to me, you can connect to this origin over on this server using this protocol, blah blah blah, and then you continue from there and you cache that information.
I was actually going to ask about that. Is that then a UDP request, like the client sends one of those first, or is that it can't be a TCP request?
Well, the initial one will be an HTTP, or you'd rather upgrade to HTTP2 probably first, and that response will say the next one you can continue on over here using QUIC, this version, blah blah blah. So
you still have the required handshaking, and you still have the setup time on that very first request, because you don't know if it's going to be a QUIC server basically until you do, and then from then on you can assume that, and you can also cache that in the client.
Yeah, and it has a lifetime, so if you have it, if you know you're going to provide that for a year, you can set up a really really long lifetime, so everyone will cache that for a long time. But there's also this, going back to the ossification and stuff, UDP is also not as successful to use over the internet as TCP is. So there's still this, single digit percentage of connections that will fail over UDP, that will sort of never handshake QUIC at all. So you still have to have that fallback mechanism to go back to H2 if the QUIC connection doesn't work. At least that is what we're doing now and for the foreseeable future.
I was going to say, now you're telling me there's no such thing as a post-TCP world then, because you're just going to be stuck with it forever.
Post-TCP first.
Possibly, how everything gets stuck. There's always something left of the old technology somewhere, so we'll never get rid of everything.
Right. Yeah, I mean, I'm really just wondering what the implications are. Like, why would the IETF is using this term now internally in their conversations? And it's like, I don't understand why you would want a post-TCP world, unless it's just maybe because it's just old and QUIC's better in every single way eventually.
Yeah, I guess it's because it then solves the ossification problem. It allows you to keep on developing the protocols freely.
That's right.
Much more freely. So if you want to implement multipath next year or in 2020, you can do that because you have encrypted everything from the beginning. So there won't be any middle boxes that prevents you from implementing new cool features that you come up in the future. So I think there's a lot of that.
Except for that first request. You still got to get it through there.
Yeah, but then, I mean, that's the current approach. I guess that there will be those who will do the happy eyeballs approach, that when you try both at the same time and you go with the one that responds and stuff like that. So I mean, that is also a solvable solution. You can probably invent something in the future that will do it differently.
So where should developers out there in open source land, where should they be putting QUIC on their radar and thinking about it more or less important in terms of maybe somebody's running a website like changelog.com, or maybe they're running a networked service like Twitch or something? Like, is this something that we should all just be patiently waiting for? Should we be getting involved? Maybe that depends on who you are and what you're up to. But what would be your advice with regards to QUIC?
I mean, it's of course a technology that if you're into low latency serving things from either end over the internet, this is a technology that is coming. So of course, getting familiar with it and how it works and what it means for you, it's a good start. But it will take a while until there are reliable and solid implementations of this. So if you want to work on code now, you're pretty early on, and you get a lot of funny things and rough edges if you try it out. But of course, it's a chance too to work on this bleeding edge protocol stuff.
So Daniel, you have the ear of the open source community. You're an elder statesman now, if you will, being awarded a medal by the Swedish king. I mean, that's something that doesn't happen every day. So you got that going for you. If you could give some closing advice on this time around to our listeners and to us with regards to open source, software development, life, whatever it is, as parting words, what would you share with the audience?
My general advice when it comes to open source and software development like this in general is to make sure that you try to find what is fun for you and work on that, because if you don't do that, you end up not doing it at all. So finding your project or your ideas or whatever it scratches, I mean, your itch, you scratch your itch, and that makes you actually do something, and that's fun, and then you can possibly become productive. And then I think you also need patience. That's whatever you do in this area of work, you need to be sure that some things just takes a lot of time. And I mean, not only sort of time to get things done, but also time to to make sure that others find your project and that you find your users, or that whatever, that you get your stuff completed. Things take a lot of time.
And speaking of patience, going back to the beginning of the conversation, the 20 years post, you mentioned Titanic. You'd mentioned that Google wasn't even formed yet. And here we just talked about Google leading QUIC, or at least beginning QUIC, and now it's where it's at now. I mean, it's pretty interesting to see the patience it must have taken on your part to deliver curl and then evolve it over years and be patient with all the change.
Oh yeah, and it's and so sort of just looking back over time and see what a different world and a different society we had back then. It's only 20 years, but most of everything we know today, it wasn't like that 20 years ago.
Well, cool, Daniel. Thank you so much for spending time with us. Thanks for coming back again. Thanks for your super awesome service to the community in ways I'm sure that the future generations of the entire world will truly appreciate. Maybe lesser than we need them to, but I mean, having something that's so widely adopted and so widely used, I'm sure it will be around forever, right? For as long as the internet needs it, right? So
yeah, exactly. As long as it's needed, it's going to be there. Yeah.
It's 20 years so far, so 20 years more at least, for sure. All right, that's it for today's episode. Thanks for tuning in. If you enjoyed the show, do me a favor, share it with a friend, go on Twitter, tweet about it, go back into Overcast and favorite it, or whatever you're using, give it a thumbs up, tell a friend. And of course, thank you to our sponsors, Rollbar, DigitalOcean, and also OzCon. We're going to be there, by the way, so if you're going to be at OzCon this year, make sure you say hi. And bandwidth for Changelog is provided by Fastly. Head to fastly.com to learn more. And we catch our errors before our users do because of Rollbar. Head to rollbar.com, and we're hosted on Linode Cloud servers. Check them out at linode.com/changelog. This show is hosted by myself, Adam Stacoviak, and Jared Santo. Editing is by Tim Smith. And of course, the beats are by Breakmaster Cylinder. You can find more shows just like this at changelog.com. And while you're there, make sure you sign up for our weekly email. Thanks for tuning in. See you next week.